So work done is basically defined as if a force is applied on an object and the object covers distance in the direction of force. That is, it's not only the force that should act on the body, there must be some distance covered when that applied when the force is applied on an object. And that motion should be in the direction of force applied. So if this is an object stationary placed, I have applied force in this direction, and the object covers motion in the direction of applied force. It will be known as work done. Work is only said to be done if and only if force acts on the body and the body covers direction, covers motion in the direction of applied force. So, if I'm standing holding a bucket of water, or I'm working on a computer sitting on a chair, or if a car is on but stationary, according to physics, there is no work done. And why is that? Because if I'm standing holding a bucket of water, my applied force is acting in the forward direction and weight is acting in the opposite direction. Okay? So there is no motion covered in the direction of force, so no work is done. Work is only said to be done if and only if there is some motion covered in the direction of applied force. Even there is some motion, but it's not in the direction of applied force, it will not be considered as work done. Suppose I'm applying force like this and the object is covering distance in this direction. So the angle is between them is 90. So according to this, we can say positive work and negative work. Work is positive if angle between the distance and displacement and force between F and displacement is zero. That is, they are parallel to each other. Obviously, if I'm applying force in this direction and distance is always getting is also in this direction, covered is in this direction. So the angle between them would be zero. That is, they are parallel to each other. So it would be known as positive work. Negative work is when theta is equals to 180 degrees. That is, I'm applying force in this direction and displacement is covered in the opposite direction. So they are at 180 degrees. You guys know that now? Okay, this is 90, this complete is 180. Force is direction में and displacement opposite direction में cover हो रही है. So work will be negative. Maximum work done कब होगा? जब theta is 0. And zero work done कब होगा? When theta is equals to 90. Theta basically tells the angle between force and displacement. Since force and displacement both are vector quantities, but work as a whole is considered as a scalar quantity. And why is that? Since force and displacement, the angle between them is zero, which is they are पैरेलल टू ईच अदर, कोई रिजल्टेंट वेक्टर ड्रॉ नहीं होगा इसमें। ठीक है, सो द ओनली थिंग वी नीड टू डिपेंड डिस्कस इज द मैग्नीट्यूड ऑफ इट, so it's a scalar one. Since I have written this down multiple times that work is dependent on force and displacement, so its formula would be W is equals to F cross T. Normally in the senior class you're going to get dot and cross का भी different meaning होता है when it comes to physics, but that we will study in the later stage. Am I clear what is meant by work done?
Yeah.
Work has a unit of joules, and joules is equals to Newton into meter, because force has a unit of Newton and displacement has a unit of meter. So 1 joule is equals to 1 Newton into meter. The greater the distance covered in the direction of force, the greater will be the work done. If the force is bigger and the distance traveled is less, the work will be less. So the greater the distance, greater will be the work done. Since a man is pushing the truck, but truck is at rest, is he doing work? What do you think?
No,
Why is that? Do you know how would you justify?
because the car isn't moving.
Because the car isn't moving. So D will be 0. So when multiplied with force, our total work done will also become 0. We could see the example here they have discussed, and they have given us the force. It's 100 Newton and distance traveled is 200 meters. So work done would be equals to 100 into 200. गिम्स कन्वर्ट किए हुए, so 2 into 20 into 10 is to power 3 joules हो जाएगा, plus 3 decimals backward move किया, and to the power of 3 is kilos, so 20 kilojoules. Okay,
Mm.
the next topic that we have is energy that gives us ability to do, energy is defined as the thing that gives us the ability to do work. So there are different types of energies that we're going to discuss in this chapter. The main two types of energies would be kinetic energy and potential energy. And rest of the energies are either the types of potential energy, or we're going to have few other forms of energies as well. So energy is defined as anything that gives us the ability to do work. Uh, Hold on. So energy is defined as which gives us ability to do work. There are different types of energies: mechanical energy and electromagnetic energy. Mechanical energies is basically those energies are dependent on medium. They require some sort of medium for their existence. Okay? And these types of energies are independent of medium. Can you think of any energy resource which is dependent on medium and independent on medium? Let me
Um,
let do you think light and sound is a type of energy?
yeah.
So out of these two, which one is dependent on medium, which one is independent of medium?
Sound needs a medium.
Yes. And light is independent of medium. So they fall
Yeah.
into these two categories of dependent and independent mediums. ठीक है? Mechanical energy की further two types जो हमारे पास आती हैं, they are kinetic energy and potential energy. So kinetic energy is basically defined as, you might know what kinetic energy and potential energy is. Hamna, do you know what kinetic and potential energy is?
Yeah, it's basically when an object has when it's in motion.
Yes. Object with motion or in motion have kinetic energy, and the energy possessed by a body due to its position or height from the Earth's surface is known as potential energy. So, due to motion and due to position is potential energy. Let's see what they have discussed here. Since work done is basically the energy is dependent on work. So whatever the unit for work is so the unit of work and energy is approximately same. Both are given the unit of joules. Okay. So they have discussed different types of energies here. Chemical energy, electromagnetic energy, electrical energy, sonic is basically sound energy, nuclear energy is basically the energy stored in the nucleus of an atom. Okay. So the chemical energy is basically the energy due to the bonds between the atoms. Arrangement of atoms की वजह से जो energy stored होती है, that is known as chemical potential energy. It is stored in our food, in our fuel, in the batteries. There are so many examples into that. The bonds, these bonds can take many different forms, including energy derived from carbohydrates in food to energy stored in the gasoline. वो जो fuels and food के बारे में मैंने आपसे बताया ना वो. Electromagnetic energy is the energy from light or electromagnetic waves. Energy from the sun from the sun supplies Earth with all forms of energies required for the sustainability of the life. Electrical energy is due to the movement of electrons. Charges की movements की वजह से जो energy stored होती है. Sonic energy is sound energy. The energy of sound waves travel through air on another medium is the sonic energy. And nuclear energy is the energy stored in the nucleus of an atom. Nuclear energy is further divided into two types, and you might be familiar with these two types of energies. The first one is nuclear fission energy and nuclear fusion energy. Fission energy is basically defined as the energy released when a bigger nucleus break down to form smaller nuclei. When bigger nucleus is broken down into two smaller nucleus, energy released is known as this type of energy is known as nuclear fission. जो हमारे nuclear reactors के अंदर जो energy release होती है, that is nuclear fission. ठीक है? And fusion is the one where nuclear fusion is defined as the energy released when two small nuclei combine to give a bigger nucleus. Like a bigger nucleus, it breaks down into two smaller nuclei. So this will be known as fission reaction. And fusion reaction is when two small nuclei combine to give a bigger one. These are normally, this fusion reaction only occurs in sun and this occurs in nuclear reactor. Or some other ways as well. Fission is possible for us, but we cannot achieve the fusion so far. Okay. यहाँ पे उन्होंने वो point discuss किया, which I was telling you. All forms of energies can be classified as one of the two types, either potential energy or kinetic energy, or termed as mechanical energy. इसको दफा रिव्यू कर लें, then we'll see कि हमने equations करनी है of kinetic energy and potential energy or not. So whenever a force is applied onto an object and there is some kind of motion in the object, only then work is said to be done. That's what we studied in the previous lesson. So obviously, if a force is being applied onto an object and there is some motion or change of position in that object, so it means work done is basically the change in kinetic energy and change in potential energy. We have discussed that change is represented by this triangle. We call this delta. So we can write it as work done and work done. Now, in physics, if we want to see whether a particular equation that we are discussing is exactly the right one, and there is no, for example, if I'm writing it as F is equals to mg and F is equals to ma and F is equals to 1 by 2 mv square and F is equals to work done over distance, so forth and so on. If we want to check the correctness of this, we need to do is okay, whether the units on either sides are equal or not. Okay. So if we check this one, since we're saying that work done is equals to change of potential energy and work done is equals to change of kinetic energy, so let's just prove that work done is equals to mgh, that is fd is equals to mgh. In order to prove that, we'll write delta H because mass and gravity would not change when a work is done on an object. The only thing that would change in the position. So we could write delta H as H2 minus H1 since this would be its final position and this would be its initial position. Okay? We are familiar with this formula that F is equals to mg, right?
Yeah.
So we can write mg in place of f and d is the displacement. Here the displacement is represented by delta h. So work done is equals to change of potential energy, hence justified. Also, if we compare the units of this, f has a unit of newtons and displacement has a unit of meter. Let's see whether it has the same unit on the other side as well. Newton किसके इक्वल होता है? किलोग्राम मीटर पर सेकंड स्क्वायर into meter, which means kilogram meter square per second square is equals to joules, which is the unit of work done. Let's see whether mgh is giving us the same unit or not. M has a unit of kilogram, G has a unit of meter per second square, and H has a unit of meters. So it would be kilogram meter square per second square.
What is the H representing?
Change in height, change in position of the object, which is basically the displacement. Okay.
Okay.
In order to discuss the kinetic energy, that work done is equals to change of kinetic energy, we need to get into the equations of motions. Do you recall the equations of motions that you might have studied in chapter number 2 or 3? Vf is equals to Vi plus At, 2As is equals to Vf squared minus Vi squared.
Uh, I don't
No?
remember.
अच्छा, these are called the equations of motions. ठीक है? Vf is the final velocity, Vi is the initial velocity, A is the acceleration, T is the time. Either A is again acceleration, S is displacement, Vf and Vi is initial and final velocity. So if I write down the formula of work done, it's equal to this, and we know that it's equals to ma. F is equals to ma, and if I rearrange this equation, and S is basically the displacement. So what would be the formula? 1 over 2a into Vf square minus Vi square. Okay? So D would be equals to this. I'll put this here in place of it. F की जगह पे ma आ गया, D की जगह पे 1 over 2a Vf square minus Vi square. A cancels out and Fd would be equals to 1 by 2 m vf square minus vi square. Since mv square is the formula for kinetic energy, so if I multiply m with each, so the mvf is representing the final kinetic energy and mvi is representing the initial kinetic energy. So hence work done is equals to change of kinetic energy. You only need to keep this in mind. Okay? Equations of motion. There are few other equations of motion as well, but since in the new book I don't think they have added these, so let's just ignore that. Okay?
Okay.
The equation they took help from is kinetic energy is equals to इसको कहते हैं work force displacement graph or area under the graph आप लोगों ने भी might not but if you could see that if area under the graph would be base into height. Base is d and height is f, so f into d हमारे पास यहाँ से आ जाएगा. ठीक है. f is represented as a ma. ठीक है, मैंने यहाँ पे मेंशन आउट किया एरिया इन द ग्राफ वर्क डन का होता है ये. So f is represented as ma and displacement is represented as v average into time because displacement is equals to sorry, speed is equals to displacement over time, and if it's the total displacement, so v average displacement to time, so I'll multiply this. V average we know is considered as v1 plus v2 over 2, right? You know this now.
Yeah.
So if the initial velocity of the object is 0 and final velocity is v, so v average would come out to be v by 2. If I place this in place of it, so it would be v over, and sorry, acceleration की भी values से put कर दिया, which is v over t. So the whole thing would come out to be f into d. F is equals to ma and d is equals to v average into time. m a की जगह पे क्या आ जाएगा v over t and v average की जगह पे क्या आ गया v over 2 into t. T से cancel out हो जाएगा. This 1 by 2 will come out and it will become mv square. तो यहाँ से भी हम इसकी इक्वेशन ड्राइव कर सकते हैं. This is the equation for kinetic energy is equals to work done and हमने उसकी वैल्यूज उसके अकॉर्डिंगली फाइंड आउट कर ली. Then we have the equation for mgh. Yes, see, they have replaced s with h in order to show that. The very last topic of today would be conservation of energy. We have discussed that previously. Conservation means that the initial and final value would remain same. So if we discuss the conservation of energy, it means energy cannot be created nor be destroyed. It could only be converted from one form to the other. Which means, according to the law of conservation of energy, kinetic energy is always equals to potential energy if no frictional effects are present. There is another formula that obviously I'll explain to you later if I'll see that formula. But for now, that's what you need to know for now. So today we're going to discuss the law of conservation of energy with respect to friction effects present and without friction. So far the formulas that we have discussed is of energy. There are two types of it, kinetic and potential. kinetic has a formula of 1 by 2 mv square, and potential has a formula of mgh. If there is no friction present, so according to law of conservation of energy, that explains us what is the law of conservation of energy? Shrino,
Yes,
what is the law of conservation of energy?
that energy can't be created or destroyed. It's only converted in different forms.
Okay? So whatever the energy is at the first place will be converted into other form of energy if there is no frictional effects present. But with frictional effects present, for example, if something is falling downwards, so which of the energy will be converted into the other form of energy? Potential energy will be converting into kinetic energy. But since friction is present, a part of this energy will have to do work against friction. So this accounts for work done against friction. So the potential energy that is converting into kinetic energy will have to lose a part of its energy in doing work against air friction or whatever the type of friction is present over there. So this shows the decrease in kinetic energy, so a decrease in potential energy, and this represents the increase in kinetic energy. Because kinetic energy, potential energy is being converting into kinetic energy. So decrease of potential energy will be converting into kinetic energy. But a part of it will be doing work against friction. So if I rearrange this equation, what will I write it down as? mgh is equals to 1 by 2 mv square plus fd. fd हम लोग already पढ़ चुके हैं, किसका formula होता है? Work done. So this will be decrease, अगर हम इसकी word equation लिखें, potential energy, increase in kinetic energy plus work done against friction. For example, if we focus on this diagram that is right in front of us, top के ऊपर क्या होगा? उसकी complete energy किस form में होगी? Kinetic potential energy के अंदर. Kinetic energy उसकी 0 होगी and total energy क्या होगी उसके पास? mgh. So total energy हमेशा किसकी equal होती है? Energy, potential energy plus kinetic energy. So potential energy is mgh and kinetic energy at the beginning is 0 because वो rest position पे है यहाँ पे. So total energy हमारे पास क्या होगा? mgh. When it will fall down, तो उसकी kinetic energy किसकी equal हो जाएगी? Completely उसकी just before touching the ground कौन सी एनर्जी होगी? Kinetic, and top पे उसकी और potential energy उसकी क्या हो जाएगा? 0. अब as we have discussed in law of conservation of momentum, energy will be converted from one form to another. Total energy disturbed नहीं होगा. For example, if at top it was mgh, तो at the bottom भी वो क्या होगी? Equation wise it would be mgh just before touching the ground. Okay, I don't think so. They have discussed the relationship, how to find that out, the interconversion of energies. But let me see if they have given, then I'll explain it to you as well. No, they have not discussed it. Just keep this in your mind. If a ball has total potential energy at the bottom, it will be converted into total kinetic energy before touching the ground. Can you guys keep this in your mind? Energy will be converted from one form to another, but destroy nahi hoga into anything. Am I clear up till here?
Yes.
Okay. So law of conservation of energy is justified as per this equation. Total energy at top is potential energy. Total energy at the bottom is again kinetic energy. Equation wise, they both will look the same. Derivation in our syllabus is not important. Let's say it's very easy. Do you want to understand how we are getting the same equation? Let's just see that as well. Give me a second.
Um,
Let's drive this equation now, that how it's mgh again at the bottom. Okay.
okay.
Can you see the screen now? Up in our book, they have said only they have written it as K at the top, its potential energy, and at the bottom, उसकी kinetic energy is 0, and at the bottom उसकी energy जो है, potential energy is 0 and kinetic energy is equal to mgh. हमने सिर्फ ये देखना है if it's at the top mgh, it's also mgh at the bottom. So how we are even seeing कि वो kinetic energy है, ठीक है? So top and bottom का meaning तो समझ में आता है कि at the top हमारे पास जो है potential energy है, so mgh है, kinetic energy is 0, bottom के ऊपर potential energy 0, kinetic energy is should be 1 by 2 mv square, but why it's coming out to be mgh? Because हमने डिस्कस किया कि हम एनर्जी को कन्वर्ट कर सकते हैं. We cannot destroy it. If it's at the top, it's only mgh. At the bottom, it should also be mgh. First, let me know if you understand the concept, then I'll explain you the equation. Because magnitude wise values same आने चाहिए. Top and bottom का easy है, in between check करते हैं कि why it's mgh again. Okay? अब टॉप पे देखें, फ्रॉम द ग्राउंड द हाइट इज h. द पॉइंट एट विच वी आर डिस्कसिंग इज पॉइंट b, वहां पे हाइट उसकी क्या है, x. सो टोटल हाइट उसका कितना बन जाएगा, अब हमने उसके हिसाब से करना. अगर हमें एट पॉइंट b देखें, सो एट पॉइंट b द हाइट वुड बी इक्वल्स टू, it's not complete h but h minus x, and kinetic energy is 1 by 2 mv square. Do you guys remember this equation? I explained to you the equations of motions होते हैं. You said it to me कि हमारे syllabus में given नहीं है, but मैंने कहा we are about to discuss frictional effects present when it comes to the energy conveyance. I have given you this equation. I guess you cannot see here properly, but it's the same equation that I have explained it to you before, that mgh is equals to kinetic energy plus work done against friction. So law of conservation of energy tells us that the energy cannot be created nor be destroyed. It can only be converted from one form to another. So when I'll add these values together, the total value will become equal to the initial potential energy which was at the top. Suppose initially the total potential energy of the ball at the top of this point was 100 joules. A part of its energy has been utilized in doing work against friction, and the rest of the energy is converted into. So, law of conservation of energy tells us that energy cannot be created nor be destroyed. It can only be converted from one form to another. For example, if we talk about potential energy or if we talk about kinetic energy, these are the kinds of energies which is already there, which is already present there. We are just taking use of it. For example, if I'm sitting idly, what kind of energy do I have stored in my body? Chemical potential energy, because of the food that I eat and the energy that we get from the sun and so forth and so on. So whenever I start working, so this energy is already there. I have not created it. Okay. It's already there, which I have taken in through food and everything that is around me. So when I start moving, that chemical potential energy starts converting to kinetic energy. So law of conservation of energy tells us that I am not creating these energies. It's already there. I'm only converting it from one form to another. For example, the example that is given in our book, that there's a shelf and there's a ball present here, and at this position, at position A, the total energy possessed by the ball would be gravitational potential energy. Well, I'll throw this ball, this gravitational potential energy will start converting into kinetic energy. So now gravitational potential energy start decreasing and kinetic potential energy will start increasing. Okay. And just before touching the ground, this is the ground, all of the energy will be converted into kinetic energy and gravitational potential energy will become zero. So energy is converted from one form to another, but we cannot create it nor destroy it. So when it will eventually touch the ground, so all of the energy will convert to, किसमें convert होगी all of the energy? Into thermal energy. Into thermal energy. ठीक है? Waste हो गया सारा का सारा. Because once you throw the ball, does it keep on bouncing up and down?
No.
ठीक है? It eventually comes to rest now. There will be a few bounces, and with each bounce, the height would reduce. For example, I've thrown this ball down. For first time, it might reach to this side. After the second bound, it might reach to this side, and then eventually it will become to rest. So at every step, the energy is converting into thermal energy. But if we'll add all the values, I will get the total energy, which was at the start of the process. So conservation of energy basically explains us that we cannot create energy, we cannot destroy it, we can only make use of it and would convert it from one form to another. For example, if we see these two diagrams, can you tell which kind of energies are being converted into one from one form to another? This is a dam. So डैम के अंदर कौन सी एनर्जी स्टोर होती है? हम ना gravitational potential energy. When I'll open the doors of the dam,
Yeah.
this gravitational potential energy will start converting into kinetic energy of the turbines. ठीक है? Or mechanical energy of the turbines, and that mechanical energy will be converted into electrical energy. ठीक है? So इस तरह एनर्जी कन्वर्जन होती हैं. कंजर्वेशन एंड कन्वर्जन में डिफरेंस होता है. Right now we are discussing both things. Conservation in a term कि when I will add all forms of convergence, I will get the total energy which was at the beginning of it. For example, if I say at this point the total energy was mgh, so at this point the total energy will be mgh again. Okay, irrespective of the type of energy, I'm only just showing it to you in form of equation. Okay. So energy, do you get the meaning of energy conversion and conservation? That whenever energy is converted from one form to another, this is known as energy conversion. And if I add all the energy conversions together, the input will be equal to the output, irrespective of useful or waste energy. ठीक है? हम सबको ऐड करेंगे द एनर्जी विच इज बीइंग यूज्ड एंड विच वाज वेस्टेड. फॉर एग्जांपल अगर हम एक लाइट बल्ब को डिस्कस करें, सो लाइट बल्ब की बेसिक एनर्जी जो है यूजेज क्या है, एनर्जी नीड क्या है हमारी लाइट बल्ब के थ्रू बेसिकली?
Electricity.
लाइट बल्ब से हम इलेक्ट्रिसिटी लेंगे या लाइट लेंगे?
Sorry, light.
ठीक है, बट उसके साथ हीट भी प्रोड्यूस हो रहा होता है. वो हीट हमारे यूज में है. डू वी यूज द हीट ऑफ द लाइट बल्ब?
No.
ठीक है. सो अब इलेक्ट्रिकल एनर्जी वाज इन टोटल, फॉर एग्जांपल इलेक्ट्रिकल एनर्जी व्हिच वाज यूज्ड बाय द लाइट बल्ब requires 100 joules of energy, out of which only 20 joule is converted into light and rest is converted into heat energy. इसको तो हम वेस्ट एनर्जी कंसिडर करेंगे, इसको हम आउटपुट कंसिडर करेंगे. ये हमारा इनपुट था. बट कंजर्वेशन ऑफ एनर्जी क्या कहता है कि हम टोटल एनर्जी हमेशा क्या रहती है? इट रिमेन्स सेम. Do you get the idea now? What is the meaning of conservation of energy? that
Yeah.
we can never destroy the energy. It only converts from one form to another, whether that form is useful for us or not. But if we add all that thing, अच्छा एक और चीज याद रखना, ultimate wastage of energy is mostly thermal energy. That is energy being used in doing work against friction, and that basically increase the there's a term used as entropy that you're going to study in the senior sections, but basically it increases the entropy of the system. Hamara earth is considered as a system. Anything that is observation is considered as a system. So whenever any energy is wasted into thermal energy, it becomes a part of that.
Like entropy means disorder in a system, right?
And disorder in a system, exactly. Disorder in a system, leading to the global warming and stuff that is going on in our world. So the conservation of energy tells us that if there are two equations that we need to understand alongside with it, if there is no frictional effects present, so all of the energy will be converted into other forms. For example, at the start, if it was kinetic energy, it will be completely converted into potential energy. But as in this case scenario, जहां से ball started falling, complete energy क्या था? GP, it start decreasing and kinetic energy start increasing. And a part of it will have to be converted into frictional work done against friction. So the equation would become like this. Decrease in potential energy minus work done. अब ये जो sum है इन दोनों का, ठीक है? If it was 100 joule, out of it 20 joule of work is done against friction. So कितना सिर्फ convert होगा? 80 joule में. So 100 minus 20 is equals to 80 joule. So 80 joule is equals to 80 joule. Conservation of energy validated रहती है. But equation हम ये use करते हैं. mgh minus ft is equals to 1 by 2 mv square. mgh is equals to 1 by 2 mv square plus 1. अब mgh initially कितना था? 100 joules. Kinetic energy कितना convert हुआ? 80 joules. And work done against friction कितना था? 20 joules. तो अब आप इनको जब ऐड करोगे, इनिशियल एंड फाइनल एनर्जी वुड रिमेन, जैसे उन्होंने यहाँ पे बताया, वो जो बॉल वाली एग्जाम्पल. At the initial point, the total energy is mgh. At the final position, the total energy is also mgh. Energy is converted into other form without, ये इन्होंने without friction डिस्कस किया है. आगे जाके इन्होंने शायद with friction भी डिस्कस किया है. I guess ये क्या है? Working against friction. हाँ ये क्या है? The second equation that I will explain to you, that gravitational potential energy is equal to kinetic energy plus work done against friction. If we look into this example, a player kicks a football of mass 450 grams, is thrown vertically upward at a speed of 22 meters per second. Now we have mass, we have speed. Neglecting air resistance, how high would it reach? हमें height को find out करना है. Air resistance अगर neglect करें तो कौन सा formula use करेंगे बच्चों? Shrino, if air resistance is ignored, which formula do we use in conservation of energy?
Um,
1 by 2 mv square is
is
equal
it
to
the
mgh.
mgh one? Yeah.
And cancel out हो जाएगा. हमें क्या calculate करना है? Height को calculate करना है. So rearrange करेंगे, height would become equals to v square over 2g. V की वैल्यू क्या थी? 22 meters per second और g की वैल्यू क्या होती है? 9.8. We'll put it into the equation, we'll find out the height of the object. Up, if air resistance is present and the ball rises only to 20 meters, what is the work done against friction? So formula हमारे पास again अब क्या use होगा? 1 by 2 mv square plus ft is equals to mgh. Okay. So m की वैल्यू क्या था? 450 grams. We'll put that. Velocity क्या था? 22 meters per second square. Height अब new वाली हम यहाँ पे use करेंगे, which was 20 meters now. Rest of the values will remain the same. We'll put it into the equation and find out the work. Okay.
Okay.
So there are two formulas that we keep into account. One is 1 by 2 mv square equals to mgh if air resistance is ignored. And the second one is mgh is equals to 1 by 2 mv square minus work done against friction. Am I clear now? So the topic that we're going to run into today is what energy resources are dependent on sun and which of the energy resources are independent of sun. Okay. Let me tell you that most of the energy resources except three are dependent on sun. All of the energy resources that we have studied so far, directly or indirectly, is dependent on sun. The three energy resources which are independent of sun are the nuclear energy, the geothermal energy, and sometimes the thermal sometimes नहीं, and the third form strictly speaking तो वो sun पे depend करता है, but generally हम उस करें तो that is tidal energy. So rest of all energy resources are dependent on sun except three. What are those? Nuclear energy, because that comes from the nucleus of an atom. The tidal energy, that comes from the tides. That is, I'll explain it to you again once more time. And the geothermal energy. Out of these two, out of these three, which energy resources you are not able to recall? Or you're familiar with all these three energy resources?
I only know a bit about like nuclear energy.
Huh?
I only know a bit about nuclear energy, and that's it, not the other two.
Okay. Nuclear energy is basically the energy that comes from the nucleus of an atom. And we divide nuclear energy into further two types. Comes from nucleus of an atom and is divided into two parts, which is nuclear fission and nuclear fusion. Okay. Then the tidal energy is the energy that comes from the tides. अब tides क्या होते हैं? You must have heard about low tide and high tide in sea. सर्फिंग के लिए करते हैं जो सी सर्फिंग के अंदर वो टाइड्स पे नहीं मूव अराउंड कर रहे होते हैं,
Yeah.
सर्फिंग कर रहे होते हैं, दोज आर नोन एज टाइड्स. ठीक है. उनसे जो एनर्जी प्रोड्यूस होती है उसको टाइडल एनर्जी कहते हैं. These tides are basically came into existence due to the gravitational pull of the moon. When the moon जो है they circle around the earth once in 24 hours. Okay, so when it is closest to the moon, earth, so it gives high tides in the sea. When it is further away from the sun, so from the earth, so it gives low tides. तो इस वजह से since tides are being created to the gravitational pull of the moon, that is why it is independent of sun. But अगर हम देखें, our whole solar system is dependent on sun. Existence उसकी है ही sun की वजह से. So even if it's moon which is creating the tides, but somehow loop के अंदर sun आ ही रहा है. ठीक है. तो tidal energy को somehow consider तो कर लेते हैं कि it is independent of the sun energy. but somehow वो आता है. The third form of energy, that is geothermal energy. Geothermal energy हम लोगों ने study किया था. It comes from the center of the earth. Center or core of the earth. Okay. Core हमारे पास क्या है? It's all molten lava. Plasma है हमारे पास वहां पे. ठीक है. So that is again independent of sun. बाकी जितने भी energy resources हैं, they are dependent on sun. But before getting into detail, अब ये तीन तो समझ में आ गया ना? Whenever the question will come कि जी explain which energy sources are independent of sun, you can name these three energy resources and will explain accordingly. Before getting into that, there is another thing that we need to understand is renewable and non-renewable energy resources. I hope 100% you are familiar with these terms. Renewable energy resources and non-renewable energy resources.
Yeah.
What is the meaning of renewable and non-renewable energy resources?
The renewable resources are those that are already present in nature, but non-renewable resources are that is actually that are not present in nature, and then like they're mostly
No,
they're limited.
no, no, not even close. Shrino,
Renewable energy is like the energy that can be used over and over, and non-renewable
yes,
is like one time.
use and cannot be used again. Okay?
Yeah.
For example, wind energy, solar energy, these can be used again and again, again and again, again. But the energy that fuel that we use in our cars or electricity that we have in our houses, once used, this cannot be used again. So energy resources which can be used again and again, reproduce हो जाते हैं. Those are known as renewable energy resources, and the resources that once used cannot be used again are known as non-renewable energy resource. We have examples, definition here as well. Non-renewable energy resources, the energy resource that is limited and cannot be replaced naturally in short time. Most of the energy we use come from non-renewable sources. For example, fossil fuels, coal and natural gas and petrol. Fossil fuels की category में ये तीनों ही आते हैं, चारों ही आते हैं. Whereas renewable energy resources and energy source that is replaced rapidly by a natural process and सनशाइन हो गया, विंड हो गया, फ्लोइंग वाटर हो गया, बायोलॉजिकल प्रोसेस हो गया. बायोलॉजिकल प्रोसेस का मतलब होता है बायोफ्यूल्स हमारे पास. ठीक है. Biomass or biofuels comes under the this category, biological processes. So यहाँ पे उन्होंने एक टेबल डिस्कस किया है. You do not need to memorize it कि एनर्जी रिसोर्सेज हमारे पास जो वर्ल्ड का टोटल एनर्जी रिसोर्स है उसमें रीन्यूएबल कितने हैं और नॉन रीन्यूएबल कितने हैं और यूज किस तरीके से हो रहे हैं. यू ओनली जस्ट नीड टू अंडरस्टैंड व्हाट इज द मीनिंग ऑफ renewable and non-renewable energy resources and their respective example. ये टेबल में उन्होंने दिए हैं. Renewable energy resources are solar, geothermal, wind, biofuel, tides, waves, hydroelectric, and wastes as fuel. Whereas non-renewable में fossil fuels and nuclear fuels हैं. बाकी इनके environmental effects भी होते हैं. Whenever we take into account, हमें energy resource को जब use करना होता है, we always take into account certain parameters जिनको देखते हुए हमने उस energy resource को use करना होता है. वो that depends, उसके 4 parameters होते हैं main. That is cost कितना आएगा, scale कितना bigger area वो cover up करेगा, environmental effect क्या होंगे उसके, and reliability उसकी कितनी, कि उसका जो fuel है उसकी reliability कितनी है, whether it's available in abundance or not. Okay. So when it comes to energy resources, we have multiple energy resources which comes under the category of renewable and non-renewable energy resources. Since we have already discussed about renewable and non-renewable energy resources, Fossil fuel is one of the non-renewable energy resource. Fossil fuels accounts for coal, oil, and natural gas that is present in our Earth's core. Not core, sorry, deep into our sea. From there, we get coal, oil, and natural gas that we use in our everyday routine for हाउसहोल्ड यूजेस के लिए भी यूज होता है फॉर आवर मैकेनिक्स में भी यूज होता है इन आवर जनरेशन ऑफ द इलेक्ट्रिसिटी के अंदर भी यूज होते हैं ऑल ऑफ दीज आर यूज इन द जनरेशन ऑफ इलेक्ट्रिसिटी एंड हाउसहोल्ड्स में भी यूज होते हैं हमारे ट्रैफिक एंड व्हीकल्स वगैरह के अंदर भी यूज होते हैं fossil fuels basically are known as hydrocarbons. Hydrocarbons mean hydrogen and carbon की combinations होती हैं. Compounds of hydrogen and carbon only are known as वो हाइड्रोकार्बन्स और फॉसिल फ्यूल्स आर मेनली मेड अप ऑफ देम नेचुरल गैस का जो फॉर्मूला होता है दैट इज CH4 व्हेन इट बर्न्स विद ऑक्सीजन इट gives carbon dioxide water and energy that energy is utilized to make electricity or cook food so forth and so on carbon dioxide is we know that it's not good for the atmosphere and water हमारे साथ produce होता है we do not see the water whenever it's burnt because why do not we see the water there अगर water produce हो रहा होता we would have been able to see that but हम क्यों नहीं देख पाते उसके why don't we observe water into this reaction because जो heat वहां पे produce हो रही होती है वो evaporate कर देती है water को it's producing but it gets evaporated immediately so fossil fuel is a non-renewable energy resource which is used in household and everything. ये create हुआ है due to the decomposition of animals and plants for millions of years ago aquatic life के अंदर and turned into chemical energy stored in fossil fuels is obtained through a process called combustion. Combustion की reaction ये होती है. There comes a question they ask कि क्या होता है. कोल हमारे पास abundance है fossil fuels के अंदर and reserves of 1 million metric ton. However, the combustion of coal leads to significant atmospheric pollution. Oil, crude oil हमारे पास जो है refining से convert होता है multiple types में gasoline, kerosene oil, heating oil के अंदर and despite the limited global reserve, it is favored over coal due to its higher energy output for the same quantity. Though it also creates pollution, but क्योंकि उसका वो ज़्यादा है as compared to coal energy production. So we go for this. No, this is not the right color for this one. Let's see this one. So नेचुरल गैस हमें पता है गैस होती है नेचुरल गैस मीथेन वी कॉल्ड नेचुरल गैस मीथेन का अपना कोई सेंट नहीं होता so we add scent into methane to be protective because we know that if we methane kahin pe exhaust ho jayega room mein so there's a possibility of fire and blast and so forth and so on हाउसहोल्ड एंड कार फ्यूल के अंदर ये सारे यूजेस लिखे हुए हैं प्लांट्स जो है वो कोल में कन्वर्ट होते हैं देन इट इज दे आर बर्न टू प्रोड्यूस इलेक्ट्रिसिटी prehistoric organisms जो हैं they convert to petroleum which is used for oil fuel and for many other uses extract करते हैं हम इसको अर्थ से and nuclear fuel is one of the non renewable and it is independent of sun whereas fossil fuels जो था वो dependent on sun है for its existence because ये जो सारा process decomposition का chemical decomposition and everything that is because of the sun. Can you elaborate on this? Any one of you कि how sun is responsible for the fossil fuels? We know that animals, plants, and everything is dependent on sun for its existence. We we ourselves need sun. Plants need sun for its production. So somehow back in Cupid, sun is this major resource of energy due to which they exist at the first place. फिर उनका decomposition से fossil fuel बना. So that's how directly or indirectly sun is responsible for the production of fossil fuels. Nuclear energy is a non-renewable energy, but it is independent of sun because ये कहाँ से आती है हमारे पास कल भी हमने डिस्कस किया था श्रीनो. It comes from the nucleus of an atom and it is further divided into two types. nuclear fission and nuclear fusion. Fission is basically the breaking up of large nuclei to give smaller nuclei, and fusion हमारे पास क्या होता है? Two smaller nuclei combines to give larger nuclei. Nuclear fission is only possible on Sun. Nuclear fission is basically occur in nuclear reactors that we have in our Earth. Aska fuel is uranium, and it produces a large amount of energy as compared to fossil fuels, and very small amount of nuclear can produce very large amount of energy, and that energy is mostly is the purest form of energy. हमारे पास environmental impacts नहीं होते, but इनका जो fuel होता है they are radioactive in nature. Are you familiar with the term radioactive?
Not really.
Radioactive elements हमारे पास वो होते हैं which emit radiations naturally, because they cannot hold any more proton or neutron into their nucleus. So they are known, so they emit radiations naturally because of their collisions with each other. So in order to become stable, radioactive elements unstable होते हैं, that's why they emit radiation. So जो fuel use होता है nuclear fission के लिए, it's radioactive in nature. Even if it's used, it still emits so much of a radiations that is harmful for the environment. जब हम उसको dump करते हैं, ठीक है, हम इसको जिस भी एरिया के अंदर डंप करेंगे, उस एरिया के अंदर दैट एरिया वुड बिकम बेरन. वहां पे लिविंग लाइफ पॉसिबल नहीं हो सकती वहां पे, क्योंकि रेडिएशंस आर हार्मफुल टू अस एंड टू एनिमल्स एंड प्लांट्स. और उसकी वजह से इसका जो फ्यूल है उसके इन्वायरमेंटल इम्पैक्ट्स आते हैं कि इवन आफ्टर यूज जो है उसके अंदर रेडिएशंस एमिट हो रही थी विच इज नॉट गुड फॉर आवर हेल्थ. अगेन यूरेनियम को भी यूज करते हैं क्योंकि जब वो ब्रेक होता है वो लार्ज अमाउंट ऑफ एनर्जी एमिट करता है. उससे हम वाटर को बॉईल करते हैं. व्हेन दैट वाटर बॉइल्स वो टर्बाइंस को रन करता है और हमारे पास क्या प्रोड्यूस होती है? इलेक्ट्रिसिटी होती है. यहाँ पे वो पॉइंट लिखा हुआ है कि nuclear energy produces radioactive waste which is highly toxic and can cause severe health issues like burn, cancer, blood and more. बायोमास फ्यूल ह्यूमन एंड एनिमल प्लांट्स वेस्ट होता है, उसको भी यूज करके वी कैन प्रोड्यूस एनर्जी. इट इज अगेन डिपेंडेंट ऑन सन एंड इट्स अ रीन्यूएबल एनर्जी रिसोर्स. बिकॉज एनिमल एंड प्लांट्स डिपेंड्स ऑन सन फॉर देयर एग्जिस्टेंस. बायोमास के अंदर मैंने बता दिया ह्यूमन एनिमल एंड प्लांट वेस्ट कंसिडर होता है. उनको हम डाइजेस्टर्स वगैरह के अंदर देयर इज अ डिवाइस व्हिच इज यूज्ड नोन एज डाइजेस्टर्स. वी पुट दैट इनटू दैट डाइजेस्टर्स एंड दे प्रोड्यूसेस गैसेस, और वो गैसेस जो है वो फिर हाउस होल्ड्स के लिए या फ्यूलिंग के लिए जो है वो यूज होती है हमारे पास. यहाँ पे उन्होंने लिखा भी है बैक्टीरिया decomposes decaying plants, resulting in the production of biogas. A ton of food waste can generate 85 meter cube of biogas consisting of methane, carbon dioxide, and hydrogen sulfide gas. The biogas is mostly composed 60% of methane, natural gas जो होती है, with the remaining portion being primarily carbon dioxide. This biogas serves as a great fuel of heat for power plants and it's considered CO2 neutral fuel since the carbon dioxide release was recently restricted from the atmosphere. Biogas is a renewable system ideal for treating liquid manure and industrial waste, providing nutrient rich, ना कि animal waste जो है वो as a fertilizer भी use किया जा सकता है. बट चूंकि ये बहुत लेस अमाउंट ऑफ एनर्जी प्रोड्यूस करता है तो ये इतना एफिशिएंट सिस्टम नहीं होता. हमने यहाँ पे लिखा देन आई एम अनेबल टू रीड दिस हाइड्रोइलेक्ट्रिक रिसोर्स लिखा हुआ है. दिस इज हाइड्रोइलेक्ट्रिक ना.
Yeah.
हाइड्रोइलेक्ट्रिक हमने बता दिया था. ये कौन से रीन्यूएबल होगा नॉन रीन्यूएबल होगा. हम ना विल इट बी रीन्यूएबल और नॉन रीन्यूएबल.
Renewable.
हाइड्रोइलेक्ट्रिक पावर जो है वो मेनली डिपेंड करती है वाटर साइकिल पे. वाटर साइकिल जो है वो सन पे डिपेंड करता है बिकॉज सन जो है वो एटमोसफेयर पे हीट अप करेगा. वाटर इवापोरेट होगा. इट गोज इनटू द एटमोसफेयर बिकम्स क्लाउड्स. क्लाउड्स के थ्रू रेन आएगा. रेन के थ्रू हम अपने डैम्स को फिल अप करेंगे. डैम्स व्हेन फिल्ड अप वी कैन यूज इट टू. जब हम डैम्स के गेट्स ओपन करते हैं तो हमारे पास पावर टर्बाइंस लगे होते हैं दैट प्रोड्यूसेस इलेक्ट्रिसिटी. फ्यूल इसका फ्री है and it is one of again the cleanest form of energy. Barely हमारे कोई environmental crisis इसकी वजह से आते हैं. But one major environmental crisis is that कि जब हम dams वगैरह को build करते हैं, so in order to build a dam we need a larger scale and for that deforestation होती है and due to deforestation we know कि environmental impacts भी होते हैं, floods वगैरह भी आते हैं, so forth and so on. Then is it solar energy?
Yeah, solar radiation.
सोलर रेडिएशंस अगेन क्लियरली सन पे डिपेंडेंट होगा और रीन्यूएबल होगा. एफिशिएंट फॉर्म ऑफ एनर्जी है एंड बट रिलायबल नहीं है बिकॉज देयर विल बी सर्टेन डेज जहाँ पे सन नहीं होगा. सो इफ वी आर यूजिंग सोलर पैनल्स और समथिंग लाइक दिस व्हिच कुड यूज और कन्वर्ट सोलर एनर्जी इनटू इलेक्ट्रिसिटी, so we are dependent on sun for its production. So a little bit of a non-reliable resource है especially in Pakistan. Sorry, मतलब not in Pakistan because यहाँ पे approximately 6 to 8 months जो है we have summers here. But somehow non-reliable सिर्फ इस बेस पे होता है कि it is dependent on sun. If there is cloud, the weather is cloudy, so sun नहीं होगा, we will not be able to produce electricity out of it. And इसका एक और disadvantage again ये होता है to produce enough energy from the solar panels we again need a larger scale of area. So जब हम larger scale of area में जाते हैं so again हमें वही सारे problems आते हैं कि flooding हो सकता है, deforestation and stuff. Okay. अब यहाँ पे उन्होंने लिखा हुआ है solar energy is harnessed in two main ways. The first method involves solar photovoltaic cell जिनको हम solar cells भी कहते हैं. Directly converts sunlight into electricity. And these cells are made up of semiconductor materials like silicon, which generate an electric current exposed to it. Solar panels are created by connecting multiple solar cells together to form a module. सेकेंड मेथड जो है थ्रू सोलर थर्मल सिस्टम के हम पाइप्स यूज करते हैं मेनली ऑफ ब्लैक एंड शाइनी सरफेस को यूज करते हैं. ब्लैक इज अ गुड एब्जॉर्बर ऑफ हीट दे एंड सिल्वर जो है वो गुड रिफ्लेक्टर होता है. तो सिल्वर जो है कवरिंग जो है इट रिफ्लेक्ट्स द सन लाइट टूवर्ड्स द पाइप्स विच आर ब्लैक इन कलर एंड वो हीट अप करते हैं वाटर को और वो हीटेड वाटर जो है हमारे हाउस होल्ड अप्लायंस हाउस होल्ड के अंदर जो है वो यूज होता है. अब अगेन ये वही वाली बात उन्होंने लिखी है कि significant land area is required to produce electricity. So solar energy is intermittent and variable because it depends on weather condition. Cloudy days and night times limit availability of sun. अब हमारे जो जितनी भी सैटेलाइट्स वगैरह हैं, दे यूज सोलर एनर्जी बिकॉज स्पेस के अंदर सन इज ऑलवेज प्रेजेंट, तो उसकी एनर्जी को हम हमेशा यूटिलाइज कर सकते हैं. Geothermal energy resource is a resource of energy which we get from the core of the earth. Again, it's abundant in nature and हमारे पास जो है large amount of energy जो है वो यूज होता है. Geothermal के अंदर बेसिकली हम लोग क्या करते हैं, we pump water to the area where the molten rocks are present. When the water come in contact with this one, they turn into steam, और वो steam जो है वो हम turbines को input पे देते हैं और उससे हमारे पास क्या produce होती है, electricity produce होती है. Again, clean form of energy है. Geothermal is abundant, does not produce any greenhouse gas emission. It is a reliable source of power that is not affected by weather condition. It is economic, it is only economical viable in certain location, because हमारे पास हर एरिया में जो है एक्सेसिबल नहीं होता अर्थ के अंदर, कि जहाँ पे हम उसको इजीली रीच आउट कर सकें जियोथर्मल एनर्जी को. बट येट अगेन काफी हमारे पास फ्री काइंड ऑफ, और इस पे ज्यादा इन्वायरमेंटल इम्पैक्ट्स भी क्रिएट नहीं होता है, बिकॉज वो को डिफॉरेस्टेशन इस तरह की चीज हमें नहीं करनी पड़ती. विंड अगेन इज अ फॉर्म ऑफ एनर्जी विच इज डिपेंडेंट ऑन सन, बिकॉज क्या होता है, सन हीट्स द एटमोस्फेयर. फॉर एग्जाम्पल उसने हीट अप किया सन की रेज ने, एयर पार्टिकल्स जो हैं विल गेन एनर्जी और अपवर्ड मूव करेंगे, बिकॉज जब एयर पार्टिकल्स एनर्जी गेन करते हैं दे बिकम लेस डेंस, एंड जो लेस डेंस होते हैं दे मूव इन द अपवर्ड डायरेक्शन. So due to that, the colder air particles take its place. So this movement of, अच्छा यहाँ पे लिख भी देता हूँ कि जो कोल्ड एयर पार्टिकल्स होते हैं more dense. So this movement of hot and cold air particles is responsible for wind. विंड इससे बनती है, और इस प्रोसेस को नाम दिया जाता है कन्वेक्शन करंट. ओके, we have waves and tides left. Do you understand the meaning of convection current and how wind is dependent on sun for its production?
Yes.
Hamna, do you get it
Yeah.
too, better? ओके. वेव्स जो है वो बेसिकली विंड की वजह से क्रिएट होती हैं, एंड सिंस विंड इज डिपेंडेंट ऑन सन, तो वेव भी समहाउ वेव्स जो है विंड के ऊपर डिपेंडेंट है, तो वो भी सन पे डिपेंडेंट होते हैं. बट दीज टू, विंड एंड सन, बोथ आर रीन्यूएबल एनर्जी रिसोर्सेज. अगेन इनसे बहुत लेस अमाउंट ऑफ एनर्जी प्रोड्यूस होती है. विंड टर्बाइंस लगाने के लिए हमें लार्जर एरिया रिक्वायर्ड होता है, अगेन लार्जर एरिया के लिए हमें डिफॉरेस्टेशन करना पड़ता है. बट अगेन इतना एफिशिएंट एनर्जी रिसोर्स नहीं है, सर्टेन डेज पे विंड नहीं होगा. जब विंड नहीं होगा तो हमारे पास इलेक्ट्रिसिटी भी प्रोड्यूस नहीं होगा, एनर्जी प्रोड्यूस नहीं होगा. सो इस तरह से इनडायरेक्टली जो है वो जो है इज नॉट रिलायबल एनर्जी रिसोर्स, एंड ज्यादा मैग्नीट्यूड ऑफ एनर्जी भी प्रोड्यूस नहीं होता. वेव्स जो है वो वाटर के ऊपर विंड के थ्रू भी आती हैं, प्रोड्यूस होती हैं. सो इस तरीके से वो भी डिपेंडेंट होती है. वेव से भी एनर्जी प्रोड्यूस की जा सकती है, बट अगेन लेस अमाउंट ऑफ एनर्जी होती है हमारे पास. एंड लास्ट में हमारे पास टाइड्स आते हैं. टाइड्स जो है वो अगेन नॉन रीन्यूएबल एनर्जी रिसोर्स है, बट इट इज डिपेंडेंट ऑन मून फॉर इट्स प्रोडक्शन. तो इस तरीके से वो उसमें नहीं है. Wave energy, also called ocean waves, obtained from the movement of surface of water onto the ocean. Wave energy converters are devices to capture kinetic energy of the waves. So salter duct method एक device होती है which is जो waves की movement के through वो साथ साथ सिंक्रोनाइज मूवमेंट होती है और उसकी वजह से इलेक्ट्रिसिटी प्रोड्यूस होती है। तो one type is point absorber, which moves up and down with the waves. This vertical motion power a system that converts the mechanical energy into electrical energy, such as hydraulic pump on electrical generator. Another type of which is floating structure that moves with the waves. The relative motion between the segment of attenuator is used to generate electricity. यहाँ पर उन्होंने दो डिवाइसेस का नाम लिया हुआ है, पॉइंट एब्जॉर्बर एंड अटेनुएटर। मैंने सोल्डर डक्स का एग्जांपल डिस्कस किया था। दोनों ही रिलेटिव मूवमेंट ऑफ वेव्स की वजह से जो है दे प्रोड्यूस, मैकेनिकल मूवमेंट ऑफ द वेव्स की वजह से इलेक्ट्रिसिटी प्रोड्यूस होती है। ये मोर प्रिडिक्टेबल होती है, रीन्यूएबल होती है, बिकॉज विंड पैटर्न, ये देखो वो लिखा हुआ विंड पैटर्न एंड ओशन करंट पे वो डिपेंड करती है। with access to an ocean openly जो है can potentially use, however technology is still in early development, इससे अभी हम लोगों ने ज्यादा एनर्जी प्रोड्यूस नहीं की। टाइड्स जो है वो ग्रेविटेशनल पुल ऑफ द मून की वजह से होता है, मैंने आपको बता दिया था, फॉर्मेशन ऑफ बल्जेस इनटू दिस एंड दिस। और रफली ट्वाइस अ डे जो है हमारे पास लो टाइड एंड हाई टाइड आती है। लो टाइड के ऊपर हम लोग जो है वाटर को एग्जिट करते हैं इनटू द ओशन, एंड हाई टाइड पे वाटर को इन करते हैं इनटू द डैम्स और व्हाटएवर द रिजर्वायर्स दैट वी हैव। तो जब ये इन एंड आउट ऑफ द वाटर होता है, ड्यू टू दैट इन एंड आउट ऑफ द वाटर, उसकी वजह से हमारे पास जो है वो एनर्जी प्रोड्यूस होती है। एंड अगेन टर्बाइंस मूव करते हैं, इलेक्ट्रिसिटी प्रोड्यूस होती है एंड वो टेक into account into that energy, ये लिखा भी हुआ उन्होंने यहाँ पे। To generate electricity, a tidal barrage or dam-like structure, reservoirs, is constructed across the entrance of the tidal basin. Uh, Gates or barrage allow the water to flow into the basin during high tide and release it during the low tide, thereby producing electricity. Another method of involves capturing high tide and releasing them through the turbines during low tide to generate electrical power from the ocean. Tidal energy systems, whether based on tidal streams or tidal energy, are considered renewable energy resource due to their regular cycle and movement. That is it about the energy resources. So when it comes to energy, हमारे पास there are 2 points that we need, two calculations that we need to keep in our minds while working on that. First is power, and the second one is efficiency. Power is basically defined as energy per unit time, or we have done work. We are already done with the work now. The topic work,
Yes.
ठीक है? So how much work is done in a particular period of time? If we start the stopwatch and see how much time is taken for us to complete that work, that would be known as power. So power is defined as rate of doing work. Rate of doing work. I've explained you like 100 times कि जहाँ पे भी rate का आ रहा है, it means कि वो particular quantity is dividing by time. Since we know that कि work done is equals to change of kinetic energy, and work done is also equals to change of potential energy. So we can rewrite the equation as E over T as well, depending upon which form of energy that we are using. Okay? So if power is equals to work done over time or energy over time, since work done is equals to change of energy, so उसका unit क्या बनेगा? Energy का unit क्या होता है? Joules, and time का unit क्या होता है? Second. So power is equals to joules per second, which can also be written as watts. Okay. So 1 watt is joules per second. You could see that here as well. Power is basically equals to rate of doing work, but we also know that power is also equals to rate of change of energy. So we can replace W with E depending upon the situation that we are in. तो इसको हम उसके अंदर प्लेस कर सकते हैं. So power is equals to work done over time or energy over time. Both work done and energy have the same units. So it would be joules per second. The power rating is normally sometimes called voltage of a light bulb, tells us how fast it will convert electrical energy into heat. A 100-watt filament bulb and a 40 watts tube light are shown in the figure. For practical purposes, पावर का एक और यूनिट भी यूज किया जाता है हॉर्स पावर. सो 1 horsepower is equal to 746 watts. हॉर्स पावर का वर्ड तो यू माइट हैव हर्ड कार्स के अंदर और उसके अंदर यूज करते हैं, इतनी हॉर्स पावर का इंजन है इसका.
Yeah.
So 1 horsepower is equal to 746 watts of energy. And there is another unit used, that is 1 kilowatt hours. 1 kilowatt hour is equal to 3.6 megajoules of energy. Because power is equals to energy over time, and energy is equals to power into time. अगर हम उसको convert करें, so 1 kilowatt into 1 hour. इसको ओपन अप करें तो 1 किलो किसके इक्वल होते हैं 1000, और 1 hour किसके इक्वल होता है 3600 seconds के. So it would be 36 watts into second, which would be equal to 3.6 into 10 to the power of 6 watts second, and 3.6 mega watts, yeah, joules, sorry, watts नहीं joules. So 1 kilowatt hour is a unit of energy which is equals to 3.6 megajoules of energy. Because we know that कि watt into second किसके equal होता है joules के. If you look into this equation, power has a unit of W, energy has a unit of joule, and time has a unit of second. So when I multiply this watt into second, ये किसके equal आ जाएगा joules के. So 1 kilowatt hour is equals to 3.6 megajoules of energy. You understand the point?
Yes.
Okay. We'll get back to the solved examples later. Efficiency is basically given as, we know that cannot all of the energy input is converted into useful output. Only a part of input is converted into useful output. बाकी सारा का सारा किस में जाता है वेस्ट की फॉर्म में जाता है. सिंस जैसे हम लोगों ने एक लाइट बल्ब की बात की थी, whenever we turn on a light bulb, we get light as well as heat. अब ये heat हमारे पास क्या है? It's a waste energy, हमें नहीं required है. So complete energy हमारे पास क्या थी? For example, 100 joule of electrical energy था, उसमें से only 20 joule has been converted into light, which is my useful output, and 80 joule has been converted into waste energy, which is not required by me in this particular case. So efficiency, let us find out how efficient a system is. So efficiency is given as useful output over input, and percentage efficiency is given as useful output over input into 100. So अगर हम इसकी efficiency calculate करें, what is the useful output in this particular case? What is the useful output here?
20 joules. Are you talking
ठीक
about
है?
that?
Yes,
Okay.
20 joules was the light energy which was actually required by us, and total input energy was 100. Into 100 cancel out तो कितना percent आ जाएगा? So our light bulb is only 20% efficient. Is this economical for us if a system is only 20% efficient?
No.
ठीक है? So we work on the system and try to make it more and more efficient. जैसे पेट्रोल के कंपैरिजन में डीजल इंजन are more efficient than high efficiency fuels को हम लोग use करते हैं to make the systems more efficient. Sorry. The efficiency basically deals with the how efficient a system is and comparisons build up करते हैं. So यहाँ से एक और formula भी हमारे पास आता है. Waste energy किसकी equal होगा? Input minus useful output. This might come in handy. So यहाँ पे उन्होंने discuss किया हुआ है कि the principle of conservation of energy suggests that energy cannot be created nor be destroyed. That is, the total energy output of a machine must be equals to its energy input. वो आपको याद होगा ना, हम लोगों ने एक क्वेश्चन किया था, mgh is equals to 1 by 2 mv square plus fd. Cause total input and total output को equal करने के लिए हमें waste energy को उसके अंदर add करना पड़ेगा. Do you recall this formula?
Yes.
Same cases here. According to energy conservation, we cannot create or destroy energy. We can only convert it from one form to another. Okay? So, however, it is found that the energy output is always less than the energy input. This mainly due to the work that must be done against frictional forces. So a car engine is designed to convert chemical energy stored in the fuel into kinetic energy. A light bulb is designed to convert electrical energy into light energy, whereas the car engine and the light bulbs are transforming some of the potential energy to desired form. A part of its energy is lost as thermal energy. So in order to find the efficiency of the system, efficiency is given as symbolically इसको लिखते हैं ऐसे n, ऐसे करके लिखता है, ठीक है? It's equals to useful output over input. If it's work done, तो हम W out over W in लिख देंगे. If it's energy, तो energy output over energy input लिख देंगे. If it's power, तो power in output over power input लिख देंगे. Whatever the factors are. The correlation between power and efficiency becomes apparent when considering the output power of a convenient process. The output power, अब obviously से आप इसको rearrange करोगे तो output is equals to efficiency is into power input बन जाएगा. So this demonstrates that power output is only a fraction of the input power determined by the efficiency of the system. In the event that the system cooperate at 100%, the output power will be equivalent to the input power. अगर 100% efficient system है, this means that all of the input has been converted into output. So such a system will be considered as 100% efficient system. Ideally that practically that does not exist. Efficiently हम लोग उसको discuss कर सकते हैं. And maybe in a senior section you'll मतलब study about that engine as well, which was a 100% efficient system. वो Carnot's engine था. कार्नोट्स इंजन आइडियली डिजाइन किया गया था बिल्कुल कंट्रोल कंडीशन के, उसके अंदर जितना भी आपने उसको इनपुट एनर्जी दिया था that's all has been converted into output. So we try to make a system as efficient as possible. As you could see here, two examples हैं. एक जगह पे incandescent bulb है और एक जगह पे fluorescent lamp है. Which is more efficient? Only 5% is light and यहाँ पे 20% लाइट है हमारे पास. ऑब्वियसली फ्लोरेसेंट लैम्प इज मोर एफिशिएंट देन द रेस्ट ऑफ इट. बाकी उन्होंने एफिशिएंसी को डिस्कस किया हुआ है कि द मोर द एफिशिएंट सिस्टम इज द मोर इट इज बेटर. बाकी उन्होंने यही भी डिस्कस किया हुआ है, इट इज इम्पॉसिबल टू हैव 100% एफिशिएंट सिस्टम बिकॉज फ्रिक्शन ऑलवेज एग्जिस्ट समवेयर. Friction lowers the efficiency of the machine. Work output is always less than the work input. So when can actual machine wasting some of the input energy is heat, which is not required. Typically, efficiencies of the transformation technology is given in a table. Electrical engine is 98% efficient. Hydropower plant is 95%. Large electrical motors are 95% efficient. 85, 55, 40, 25 and 20 and incandescent dump हमने already study कर चुके हैं. यहाँ पे एक उन्होंने solved example दिया हुआ है कि we have an input of 40 joule which converts into 120 joules of useful work. Efficiency कैसे calculate करेंगे? What is the formula of efficiency? Useful output
Useful
over
input. Sorry, use input over
output over input, not input over output. Output over input.
um
So
okay.
useful output कितना है हमारे पास?
120 joules.
120 joules and input हमारे पास कितना है? 400 joules. So we'll
400
divide it
joules.
and we'll get the answer. Multiply by अगर हम 100 कर देंगे percent efficiency करनी है तो 0.3 into 100. So it's only a 30% efficient system. Therefore, such a petrol engine will only be 30% efficient, but that is कि वो सिर्फ 30% workout दे रहा है, बाकी rest of the 70% कहाँ पे जा रहा है? As a waste energy जा रहा है हमारे पास, ठीक है? Which means that such a petrol engine will be 25 efficient. It will only do 1/4 of the useful work of the provided input fuel. फिर हम fuel की quality को better करते हैं, engine की quality को better करते हैं, so that हमारा जो maximum fuel है, it should be converted into output, so that हमारा system जो है वो efficient हो सके. This is one example we skipped in the power section, and उन्होंने discuss किया हुआ था. In terms of horsepower से बात की हुई थी. How powerful will be a Tesla car engine if it's 3 into 10 raised to the power 7 joules work in 1 minute? What will be its power in horsepower में सबसे पहले पावर का फॉर्मूला हमारे पास क्या होता है? वर्क डन ओवर टाइम. वर्क इज गिवन एज 3 into 10 raised to the power 7 and time is given as 1 minute, तो सेकंड में कन्वर्ट करके डिवाइड बाय 60 कर देंगे. सो आवर आंसर वुड बी 615 किलोवाट्स. हमें हॉर्स पावर में लेके जाना था, तो 1 हॉर्स पावर इज 746 वॉट्स. तो 1 वॉट किसके बराबर होगा? 1 over 746 हॉर्स पावर के. तो 6.5 615 किलोवाट्स को मल्टीप्लाई कर दिया हम लोगों ने 1 over 746 से. And our answer came out to be 825 horse power. That is the end of this chapter. As you have just said that you have reviewed most of the chapter and you do not have any question, go ahead and review these topics and let me know if you have any questions from there.